Hi, and welcome to Semcadia. This activity is called Moon Thermos. There is no atmosphere on the moon, so temperatures fluctuate through a very wide range. In the shadowed areas of the moon, the temperature can be as low as negative 300 degrees Fahrenheit, and in the sunlit areas, it is about 212 degrees Fahrenheit, which is the boiling point for water. These are severe extremes for human beings. Furthermore, there are spots on the moon that are permanently exposed to the sun, and others permanently in shadow. It is in the permanently shadowed areas of some craters that scientists believe water ice may exist. Anyone living on the moon, even for a short while, will have to deal with this temperature variation and be protected properly from its damaging effects. Just think about the number of layers you wear when going outside on a very cold winter's day. The goal in designing a spacesuit is to create protective layers to keep a human body at a fairly constant temperature. Therefore, we must understand how heat moves. Engineers need to design protective wear to prevent heat from being transferred to or transferred away from our bodies, just like how a thermos works. To understand how a thermos works, we must first understand the processes of conduction, convection, and radiation, the three processes through which heat is transferred. Conduction is the transfer of thermal energy through direct contact. Temperature is proportional to average kinetic energy. Molecules with high kinetic energy, high temperature, bump into molecules with low kinetic energy, transferring some of their kinetic energy through these collisions. Convection is the transfer of thermal energy through the movement of a liquid or gas. Molecules with high kinetic energy is less dense than molecules with low kinetic energy because molecules with high kinetic energy are moving around more and pushing each other away. Because cooler molecules are more dense than hot molecules, cooler molecules move around and underneath the hot molecules as the hotter, less dense molecules start to rise. Radiation is the transfer of thermal energy through thermal emission. As charged particles become accelerated through bumping into each other, they release electromagnetic radiation. Electromagnetic radiation. As molecules become charged from bumping into each other, they accelerate. Here's why the thermos or vacuum flask is such a good insulator. Conduction can't occur in a vacuum. It only occurs in matter, and there's no matter in vacuum. Convection can't occur in a vacuum. It only occurs in fluids such as air, and there's no air or any other fluid in a vacuum. Radiation can travel through a vacuum, but electromagnetic waves bounce off the flask's reflective walls, greatly reducing heat transfer by radiation. For this activity, you're going to need a plastic cup, a stopwatch, you could use your phone, a thermometer, and some water. For insulation materials, you're going to need bubble wrap, tin foil, some cloth, and some paper. This experiment requires a control, so put cold water in an uninsulated cup, then record the temperature every 30 seconds for 5 minutes. Then do it again for warm water. Next, using any combination you'd like, create a protective insulating layer that keeps 3 ounces of cold water and 3 ounces of hot water at a relatively constant temperature. Moon thermos temperatures should not change any more than 40 degrees Fahrenheit within 5 minutes. Place cold water into the cup. Then for every 30 seconds, for 5 minutes, record the temperatures. Next, do it again for warm water. In a second trial, try to improve your design by trying another combination of materials. Finally, graph the results.